Hello, good evening everybody. I'm Sam Sutherland. I'm the Technical Director at ZAM Consulting, which means I people manage all of our technical team, look after our technical direction, how the business is going in the technical space and all things technical. I say technical a lot in my job. Anybody know what happened on this date?
ChatGPT 3 was released.
Exactly, ChatGPT came out. And we all went, wow, this is cool. This is really cool. Genuine language understanding and language generation that we could actually get on with. And we all had to play with it. Then we kind of went, well, now what I really want to do is talk to my own data. So people in organizations wanted to take it past the data that ChatGPT actually knew onto our own data. So how do we do that? Well, there's two main methods. First one is fine-tuning. So this is retraining the existing model with some new data, which you can do if you've got a specialized task that you want that data to be able to do, then you can fine-tune it. It's expensive. You have to have a lot of machine power to do that, and you have to have technical abilities. You need a data scientist to be able to do that. So it's kind of prohibitive for a lot of organizations and particularly individuals. Option two is what's called retrieval augmented generation, or RAG. So in this paradigm, the model doesn't change, the LLM stays the same, but what you do is you provide new data to it, and you can provide that new data as often as you want with fine-tuning. Once you've fine-tuned your model, it's fixed again. And if you want to add more data, you've got to re-fine-tune it. With RAG, you can just add new data as often as you want to. And what you do is you index that data into a vector database, as Stefano was talking about vectors. Ties in nicely. You put it into a vector database. And the way you do that is, or the way you set it up is kind of like this. So first of all, you deploy your LLM. Usually, if you're doing RAG, you're doing it on your own private data, which means that you want your own private model with it as well. So you deploy your own model into the cloud, usually, because you don't want to send your own data into ChatGPT or into the public cloud, because they'll use it to train the model on. And there was a story, I think it was Samsung in Korea maybe, some employees got fired because they put private data into the public cloud and it used it and it gave it back to somebody else. So don't do that. So deploy your own LLM into the cloud. And the next step is to take your own data set and do something called chunking. So it's basically splitting it up into small chunks of text, of data. Those chunks are then indexed. So this is when the vector is generated, so the number that represents that bit of text is generated during this process and put into a database. So you've got your chunk of data and then a numerical representation of that data, basically, in a database over here. You want to be able to talk to that, so you need to deploy a front end or create a front end. You could use React or Flutter or anything like that maybe. And then you need to connect it all together. So you need what's called an orchestration layer, so something to move the data. You're doing your sort of traditional chatting with ChatGPT. You've got your LLM down here, or a service that hosts an LLM, that you would put your question into the UI. That would send it over to the LLM to do the natural language processing and actually understand what your question means. And it would transform that into a vector as well. So you've got a number representing your question. And then what happens is that number is, the database is queried for that number or a number that's similar to it with a bunch of maths that goes on. But basically it'll find, say I've indexed my company's HR policies, sorry. I might ask it, how do I book a day off? And so the LLM would transform that question into a vector, find similar data in this database, and then send it back to the LLM to generate an answer for me, and then send that back to the UI. Okay, so here's an example of RAG. This is a nice bit of kit called Anything LLM. It's it comes in a container, so you can spin up a container, put it into the cloud, and then hook up an LLM on a service. And then I actually did upload some of my HR policies into this and asked it a question about that. So how do I use my employee assistance program? And it's generated an answer there for me. That data hasn't come from the LLM, it's come from my own private data on that. So yeah, I would recommend Anything LLM if you want to have a play around with RAG. So again, people got into RAG and they're like, yeah, this is brilliant, but then came up again against some problems with it. So the first one is it struggles to connect the dots. So if you've got some information that's kind of across different points across the data that you want to connect, it can't do that because the data's chunked up, so you can only really find the data that's in one chunk at a time. And the other one is that you can't summarize if you've got a really, really large corpus of data, like we've got a customer that's doing 20 million documents. You can't obviously put those into a context window for an LLM query it. And RAG struggles to summarize all of that data in one go as well. So what's the solution? Is marrying up to a knowledge graph. A knowledge graph organizes your information into nodes, so these circles are the nodes representing entities, and then the relationships between those nodes, which are all the lines, and then each node has attributes as well, so information about the entity, and then these are organized into what's called communities, so the different colors are the communities. So marrying those two technologies together, RAG plus knowledge graph gets you GraphRAG, which is able to connect information across large volumes of information and use these connections to answer questions where the answers span many documents, as well as thematic questions such as what are the top themes in this database. So you can look at all of the data in one go. So how does that work? So the indexing starts off the same. Again, you need to chunk up the information into those chunks. They're, again, stored with a vector in the same way that RAG does it. But then you get these extra layers. So what happens then is those chunks are sent back to the LLM to extract the entities. So, you know, the people or the objects or whatever it is that data concerns. And then those entities are summarized. So you've got the raw data, and then you've got a summary of the entities at a layer above that. And then those entities are grouped into those communities. So these different colored things are the communities. It's grouping of entities together. And then those groupings are then summarized. So you have these three layers of data. So the raw chunks, the entities, and then the communities at the top. And then what that allows you to do is these two new methods of search. So you've got a local search, which takes basically the bottom two layers. You've got that raw data, plus the relationships between those entities. And so you can ask it a question that requires an answer that's pulled from different entities, and where regular, they call it naive RAG, would only be able to pull out distinct separate parts of data. That knowledge graphs allows it to pull out the data that's got relationships to each other, so you get a better answer. And then the other search mode is global search. So we can answer questions like, what are the themes of this data? So it's able, at that top level that's got the summary of the communities, that's a very, very broad view of the data. Disco time. With that very broad view, we can do a global search and say, hey, what are the themes of this data? What's actually going on across all of this huge corpus of data that I've indexed? And then so just to give you a couple of examples, don't worry about actually reading the text. This is kind of trying to highlight the difference between them. So this is a connect the dots problem, a baseline naive RAG. Couldn't find anything, couldn't really find any connections between those bits of data that were indexed. But with a GraphRAG and the knowledge graph on top of it, it was actually managed to pull out these different events that were related to each other to this entity. And then with a global search as well, they asked it a question, what are the themes of this data, of this very big data set? Now, regular RAG did manage to find some things where those individual chunks were referencing a theme, but with the community summary over the top of that, it's actually much more knowledgeable about the themes and able to pull those different bits together and give you a much better answer in terms of theming. So yeah, essentially GraphRAG is a way of supercharging your RAG. If you get to that point where you've got a huge amount of data, so maybe 20 million documents, we're actually using this with that particular customer to solve that kind of problem. Then that is something that you can look into. Thank you very much. Behind that QR code, there's a few links. There's one to the RAG paper, there's one to Anything LLM, which is that really useful tool, and most importantly of all is my LinkedIn, so hop onto that one. Thank you very much.